Good day, everyone. So today's lesson, as we go through this virtually, is going to be continuing our thoughts and expanding our thoughts on the idea of circumference and area for a circle. So before we kind of expand our understanding of these two formulas, we need to first write them down. So as a review, we did find out these formulas last week. We looked at them and we actually used them a little bit last week. So just as a reminder, our circumference formula is the one that has the pi multiplied by diameter. The area formula for a circle, area, equals pi multiplied by our r squared. Some other reminders is that d stands for diameter, which again is the distance from one side of the circle through the center all the way to the other side of the circle. Radius, on the other hand, that's what the r stands for, that is the distance from the center of the circle to the outside. So it doesn't go from side to side, it's just half of the circle. It's that little half of the circle. Another added reminder that we're going to be needing today, and I'll kind of put it over here in the circumference formula, can kind of come in handy, is that diameter is the same thing as 2 radius put together. So diameter, this is not actually the circumference formula, so you might want to find a way to rewrite that, but diameter is equal to 2r. So that's just some extra knowledge. It's not actually the circumference formula, but we will kind of need that later as we kind of advance our understanding of circumference and area. So hold on to those two main formulas, circumference and area. We will be using them later today. Last week on Thursday. Last week on Thursday, we actually got these two formulas, and we looked at them saying, okay, well, if this is your diameter, what's going to be your circumference? Or if this is your radius, what's your area? Things like that. We're going to build on that understanding and kind of make it a little more complicated. So first, I have a little bit of a warm-up here for you guys. I would like you guys to give this warm-up a try by yourself. It's not super complicated, so if you want to take a second right now, pause the video, hit the little button that's like 2 lines. It stands for pausing. We're all familiar with it. Go ahead and hit the pause button and go through these 4 problems and see how you do on them. So again, everyone should be hitting the pause button right now. If you haven't hit the pause button, hit it. Go ahead, do it. Hit the button, pause it. Okay. Once you're done the problems, you can go ahead and unpause the video, and I'm now going to go over these problems with you. So the first 2 are pretty straightforward ones. They're literally just asking you to say what is the diameter when they give you the radius, and then over here, what is the radius when they give you diameter. So it comes back to that principle I set up here. I knew it was going to come back. That idea that diameter is just 2 r's put together. So down here with the first problem, it says, what's the diameter? Well, the diameter is 2 of these r's put together. So I could kind of draw it in here if you wanted. Here's the radius. We're going to have another radius on the other side. So 2.2 here, 2.2 here. So my total distance from side to side is actually going to be 4.4. So my diameter is 4.4 millimeters. In the second problem, they give you diameter, which is the whole thing, but they're asking you for radius. So they really just want half of that measurement. So we want to take a 7.3 and divide it by 2. That should give us, divided by 2, that should give us a 3.65 as our radius, and I'll throw meters on there because that is our units. Number 3 and 4, these ones actually go into using your area and circumference formula. So they want you to find the area and the circumference. So the area formula, just a reminder, is the pi r squared. In this case, they give us r. That's super convenient. So I'm just going to plug in my r. That's 3.6 being squared. Make sure that you actually square the 3.6 first. That should give us a 12.96. Now we are ready to multiply that by pi. So make sure that you actually use the pi button and not 3.14. Use the actual pi button. And you should get yourself a 40.72. Circumference, on the other side over here, our circumference formula, a little bit more simple. That's pi multiplied by diameter. They do in fact tell us the diameter, so we can just go ahead and plug that directly in. So my diameter is 6. So in my calculator, all I have to do is 6 pi, which should have given you an 18.85, assuming you rounded correctly. So again, hopefully you paused the video and did those problems by yourself, and hopefully you got them right. What we're going to be building upon today is kind of actually thinking in reverse, and this is where it gets a little tricky. So we might all be comfortable using the formulas at this point. Even if they give us radius and they want diameter or things like that, we're pretty comfortable working between the two formulas. Now what we're going to be doing is thinking backwards. So if we look at the directions, it says, how can we find the radius and diameter of a circle when we know area or circumference? So rather than them giving us the radius or them giving us the diameter and then us calculating the area, now it's going to be the other way around. So in example 1, they give us circumference. So we are talking about circumference here, so it would be helpful to write down our circumference formula. Our circumference formula says that the circumference equals pi multiplied by the diameter. Let's stick with that fact for a second. The circumference, they come right out and they say that the circumference right here equals 18.86. So let's plug that in for our circumference. Now I'm going to have 18.84, I think I said 6 earlier, but it's a 4, equals pi multiplied by diameter. And I can make that d a capital if you want. Doesn't really matter. So at this moment, this is kind of the equation that we have. They're asking for us to solve for our missing variables, either diameter or radius or both, that type of thing. Well, according to what we have right here, we have an 18.84 equals pi multiplied by diameter. If I want to solve for diameter, I want to get the d variable alone. All I'd have to do then is get rid of pi. Well, right now it's pi multiplied by diameter. So how would I get rid of pi? By dividing by pi. So I'm going to go ahead and divide both sides by pi. So that means on my calculator I need to do 18.84 divided by our pi symbol. And that gives us 5, sorry, I'm going to write this down, here we go, 5.9969. I'm writing out all the numbers because I want you to see. I'm going to round that up to just 6 due to, you know, how many decimals it has. But ultimately the pi's cancel out, leaving us with diameter on the right-hand side. And then over here, 18.84 divided by pi should give us approximately 6. So that means down here under diameter, we got our diameter to be 6. Now, going back to actually what we kind of did up top here, if we have diameter, how could I find radius? Well, up here, if we had diameter, I just want half of that in order to find radius. So half of 6 would be 3. That's my radius. So you use the formula to find either diameter or radius right off the bat. Then once you have diameter, you can backtrack and find radius. In the second problem, this is again an interesting one. This time they give us area. Okay, so not to be concerned, it's the same thing as circumference, we're just doing the area formula now. So let me write out my area formula. Area equals pi multiplied by radius squared. So in this problem, they give me area. So I'm going to plug in area over here. That's going to be 40.69 equals pi times radius squared. Don't be concerned with the fact that it's currently radius squared. We're still going to handle it just like we did circumference. Right now, looking at this problem, 40.69 equals pi r squared. The only variable that I have is radius. So I want to solve for radius. How do I get radius by itself? Just like we did over here with circumference, we're going to go ahead and get rid of that pi. So I need to divide both sides by pi. So I need to use my calculator, 40.69 divided by our pi button. When I divide it by my pi button, that gives me 12.95 equals, and again the pi is canceled out, so that gives me r squared. This is the only difference between the area and circumference process. Usually with circumference, you got diameter and you'd be done, and you could kind of write that down as your answer and move along. With the area formula, the issue is that I don't know what r is, but I do know what r squared is. So the issue here is really that square. We can't say what radius is until I get rid of that square. So how do we get rid of a square? This is where it gets interesting. In order to get rid of a square, we do the opposite of a square, just like over here. You know, pi multiplied by diameter or by radius. Opposite of multiply is divide. The opposite of a square is a square root. So we're going to square root both sides. So I need to go to my calculator, type in square root of 12.95. That gives me 3. Ooh, that's going to round. I'm going to make that a 6. 3.6. Let me fix that decimal. And now on the other side, the square root and the square cancel each other out, leaving me with just r. And now I finally have my radius to be 3.6. And then last but not least, we still need to find diameter, but that's a piece of cake now that I have radius. So radius is diameter is 2 of our radius. So I need to do my 3.6 and basically times it by 2. I want 2 of them. So that should give me a 7.2 as my diameter. So this is kind of taking our formulas to the next level. At first they gave us radius or diameter, like up top here in the warm-up. They give you radius and diameter and you just plug it in and solve. Down here it's kind of thinking in reverse, but you are still doing that process of solving for the variable. The only difference is instead of solving for C or solving for A, like we did in the warm-up, now you're solving for your diameter or your radius, depending on the problem. Okay? So I would mainly focus on, can you do the process of finding the, variable that's in the problem? Because once you can figure out what diameter is, or if you can figure out what radius is, then it's not too bad to go back and say, well, if I have diameter, what's my radius going to be? Or if I have radius, what's my diameter going to be? Because then it falls under exactly what you did in the warm-up with problems number 1 and 2, where once you have the radius, it's easy to find diameter. Once you have diameter, it's easy to find radius. But you need to find at least one of those. You either need to figure out what is the diameter, like we did here, or what's the radius, like we did here. You need to find that first, and then it can lead you to the other missing one that you have. Okay? So that's kind of the area and circumference formula kind of on a deeper sense, rather than just mindlessly plugging in the numbers they give you. Now we're kind of working backwards to find the diameter or radius. So that is it for our notes today. There is no homework for tonight, so you can have the night off. But come tomorrow during class, notice how it says classwork. During class, you will be going through this worksheet, which is exactly like what we just did in the notes. They give you area, and they want you to find radius. They give you circumference, and they want you to find diameter. Come down here, some more circumference problems. So be very careful what they ask you to find, because it does change. For example, here's another circumference problem, but this time they're asking for radius, versus up here they ask for diameter. So make sure you do pay close attention to what they're actually asking you to find. So the circumference formula might give you diameter, but they're asking you to then find radius. So make sure you kind of take that last initial step to kind of figure out exactly what they're asking for. So just because the circumference formula has the diameter in it, you have to find diameter first, then backtrack and figure out what radius will be based on your diameter. Okay? So it's just 6 problems. Each problem you're not doing both radius and diameter, you're just doing whichever one they ask you for. Sometimes you end up doing both anyways, so if you're the kind of person that you want to go through and just find both regardless, that's fine. But definitely make sure you find whichever one they specifically ask you for. So that's what you're going to be doing in class tomorrow, and then you will be doing your Brain Genie later in the week. And that's it for today, folks.